Okay, so still probing molecules and atoms and what they look like and what we're dealing with when we're talking about them, right? So we're going to spend this section, chapter 3, section 4, thinking about what these materials are at the very lowest level. So we're going to consider, atomic elements, molecular elements, and molecular compounds and ionic compounds in this section. So sometimes flowcharts are good for us. They can be a little bit overwhelming, but let's consider this. Suppose you've got a pure substance, and what I mean by that is it's not a mixture. So you've got a pure substance. And the pure substance could either be a compound, which means it's got more than one element in it, right? That's what compound means, more than one element or not, right? Now, if it has more than one element, it might be a molecular. That means it's got covalent bonds in it, or it could be ionic, which means it has ionic bonds in it, right? Okay, so I don't have my textbook ready to go. I'm not even going to hit the pause button on this. I'm just going to ask you to wait for me while I pull it open. Chapter 3, Section 4. Chapter 3, Section 4. And we're going to say, all right, so if you have, suppose, let's go back over here. Suppose you've got more than one element in your pure substance, and so it's going to be a compound then. And if it's a compound, suppose that it's got metals and nonmetals in it, or the bonds are covalent. Covalent means metals plus, oh rather, I'm sorry, no. Only nonmetals, no metals in it. Okay, only nonmetals. And you learned last chapter how to find if something's a metal or not. So suppose it's only nonmetals, then it's going to be covalent, right? Hydrogen's not a metal, oxygen's not a metal, so it's covalent. And if it's covalent, then we're going to call it a molecular compound. Can you read my writing? A molecular compound, okay? So a molecular compound is described as give me a second here. A molecular compound. Molecular compounds are usually composed of two or more covalently bonded nonmetals. All right, the basic units of molecular compounds are molecules, and they're composed of their constituent atoms, okay? The basic units of molecular compounds are molecules. All right, that's sort of intuitive. By the way, this is on page 84. Okay, now suppose that you've got more than one element in your pure substance, so it's a compound, but it has a metal in there too. So it's going to be a metal plus a nonmetal, and you're going to have then ionic compound, right? See a metal and a nonmetal? Okay, so this is an ionic compound, and the basic unit can you see that this purple ball here doesn't belong to that green ball or that green ball or the one below it? These are electrostatic interactions. These are not bonds. But you might say, all right, well, let's say those two belong together, and these two belong together, and these two belong together, and these two belong together, right? And these two belong together, and you can see that you're going to have to go out considerably further. This guy's green partner is not shown in the picture. It's down further, a little ways over. Okay, so the formula unit is going to be a green and a purple ball, right? So the basic unit of an ionic compound is called the formula unit, and it's the one where it's the electrically neutral. That is, if you've got plus one and a minus one, they pair up. That's your formula unit. All right. Now let's go back to pure substances. I don't think I said what an ionic compound was. Ionic compounds are usually composed. I'm on page 85. Ionic compounds are usually composed of a metal, ionically bonded to one or more nonmetals. Tro uses the word bond. I'm saying it's an electrostatic interaction. We're going to go with Tro's definition. Ionic compounds are usually composed of a metal ionically bonded to one or more nonmetals. The basic unit of an ionic compound is the formula unit, which we've already said. So there's no molecules in ionic compounds. All right, now let's go back upstream. I'm going back to page, say, 83 or 82. Suppose we've got a pure substance and we find there's not more than one element in it. If there's not, then we're just going to simply call it an element. Only one element in the substance. Okay? Only one element in the substance, and so it's going to be called an element. All right, well now, sometimes elements actually in nature will show up as two atoms bonded together as a molecule. So sometimes they don't, right? This is more common, by the way. But page 82's got a definition of an atomic element. This is an atomic element right here, as you probably can see. Well, you definitely can't see it. An atomic, man, my handwriting's getting horrible. Atomic element, okay? Page 82 says atomic elements are elements that exist in nature with single atoms as their basic unit. So the basic unit here is an atom, right? Okay. The molecular elements show up in nature as molecules, right? So you can see this is elemental because it's not a compound because I don't have more than one element in there. If red represents oxygen, which it typically does in most textbooks. But it is a molecule, right? Because there's two atoms that are arranged together in a specific geometric arrangement, and they're bonded, right? It's covalent, by the way, of course. Why would I say of course? My handwriting is getting horrible. Okay. It is covalent, of course. Exclamation point, and of course. Okay. So, did I already read the definition of molecular elements? Molecular elements do not normally exist in nature with single atoms as their basic unit. Instead, they exist as molecules, two or more atoms of the element bonded together. Okay, so this is molecular elements. If I go slow, I bet this will keep up with me. Molecular element. Okay. All right. Now, how do elements show up in nature? Well, you might say, let me go back for a second. You might say, well, how am I going to know if an element is atomic or molecular? That's a good question. You have to be told, really. I don't think it's obvious. It becomes obvious later, but for now, let's say what's a good rule of thumb? So how do elements show up in nature? Well, elements that show up in nature as diatomic molecules are here. And there's not many. You can see that, right? Those guys there usually show up as diatomic molecules, and this guy. Okay? What about elements that exist as polyatomic? That is more than two, right? Di means two. Two atoms in each molecule. And polyatomic means more. Can you read my writing? Than two atoms in each molecule, okay? And there aren't many. It's phosphorus, sulfur, and selenium, okay? So elements that exist as diatomic molecules in nature are mostly in yellow here, and the ones that show up as polyatomic are here. I'm afraid in a slide previously, a few minutes back, maybe even this very video, I said that most elements show up as diatomic molecules. That's not a fair statement. As you can see, this is clearly not the case. Nevertheless, we are going to be dealing with these atoms a lot. Very common. Very common. very common. And oxygen and nitrogen, very common. And hydrogen, very common. So maybe I should have, if I said that, I'm not going to go back and edit it out, but if I said that, let me change that to the ones that we will see most often, especially as gases, are going to be diatomic, okay? So the gases that we see in future chapters, it's very common for these to be diatomic if they're elemental. Okay? So let's give it a couple examples. An ionic compound we've already seen is sodium chloride. We saw that in a previous slide, in a previous video, the one we did for ionic compounds. So an ionic compound is going to have a bunch of ions in it, right, in an array. A molecular compound is going to have things bonded, right? So here's an example. This is an LP tank. You know what LP stands for? Liquid propane. Okay, it turns out if you open this up, it'll come out as a gas, but when it's under pressure, it's in there as a liquid, making little wavelets in there, right? So, and that liquid, it looks kind of like this, right? You've got these little molecules in there, and it's covalent because it's C3, you can't tell from looking at that, C3H8, and this is a nonmetal, and this is a nonmetal, right? So a nonmetal bonded to a nonmetal is going to give us a covalent compound. An ionic compound is going to be a metal and a nonmetal. Okay, so in review, elements are either going to be atomic or molecular, and we call the smallest unit of elements, we call them atomic elements, we call them atoms, and the smallest units of molecular elements we call molecules, of course. Now, compounds can be either molecular or ionic. The smallest unit of compounds we call molecules. I'm sorry, smallest unit of molecular compounds we call molecules. I realize it sounds redundant, but it's worth appreciating. And then finally, ionic we call the smallest unit of these, the formula unit. Okay. All right, and then I guess I want to leave you with a question. What about polyatomic ions? So polyatomic ions, it turns out, an example that we used, do I have one here in the slide? Yeah. So a monatomic ion we've seen before, right? Where sodium, which is a metal, has a tendency to give up an electron, right? And so after it's given up the electron, it's left as a sodium cation, right? And that's a monatomic ion. In other words, it's one atom in the ion. Okay? But a polyatomic ion, this is something you can buy at the grocery store. This is it's very inexpensive, very cheap, very safe, very good for you. It doesn't taste very good though. Sodium bicarbonate, right? This is bicarbonate here. So this is an ion, really, and the ion's name is bicarbonate. And the formula that we have for that is CO3H minus, okay? So, and the name of it is bicarbonate. Can you see, though, that we've got lots of nonmetals in here? There's a nonmetal, and here's a nonmetal, and here's a nonmetal, right? So they're bonded to each other with covalent bonds. Covalent bonds. But the interaction between these guys now, that's going to be ionic. So it's important to appreciate with polyatomic ions that you can have covalent bonds within the ion, but between this ion and that ion, that's going to be an ionic bond. Okay, I think I have an example here in the next slide. So classify each substance as an atomic element, a molecular compound, or ionic compound. So really, first thing you should do, this is on page 85. First thing you should do is you should open your book to page 85. Where am I here? Pen. This is on page 85. You should open your book to page 85 and look over to page 84. Look at page 84, and you will see when you do that you have this periodic table over on page 84. Right? Remember this? Okay, so now that we've got that, and you should do this with stuff right in front of you, so you'll get used to it, and it's a huge benefit. You should not do this straight from your head until you're comfortable with it. So classify each substance as an atomic element, molecular element, molecular compound or ionic compound. All right, so if I see xenon, you might have to, I don't know, Google that or look it up in your book. I'm not guessing it would immediately know that xenon was right there, but I see that's an element, right? Look at that. That's an element. Now, is it yellow or red? No, it's not. And so this is going to be xenon is going to be an atomic element. In other words, it doesn't show up as a molecule. There's not, like, this is what you don't see. Make a little note here. Xenon, you don't see a diatomic molecule of xenon, right? No, because it's not here in the yellow or polyatomic in the red. Okay. Nickel chloride. Okay, so it looks like I've got a metal and a non-metal. You know what? I should have commended you in the very beginning to please pause the video and make your own guesses. You should work your way through this yourself based on what you know. Very important practice. Do that now. Okay, I'm going to suppose that you paused the video when I told you to because you are a coachable athlete and I'm a strong coach. And I'm going to suppose that you've done that, and I'm going to tell you what the answers are. There's metal, a nickel is a metal because it's right here, right? And chlorine is not a metal because it's right here. See that? And so this is going to be an ionic compound. Because I have a metal and a non-metal in it, right? That makes it ionic, guaranteed. It's that simple. What about C? Bromine. All right, so again, you might not be that familiar with bromine, but you need to get familiar with it. So you should, pause the video now if you didn't do it previously. Look up what bromine is. It's an element, and it's right here, bromine 35. So since it's an element, I know from the previous slide, it's either atomic element or it's a molecular element, right? And I see, bromine's right here. And so it is a diatomic element. So it is molecular. Can you see how much, how good it is to put your hand on the handrail? Or I guess I might consider this to be like a training wheel or something like that. It's very important to do this when you're practicing. You'll learn so much better if you have these tools in front of you. Okay, D, NO2. All right, so I see I have a compound here, so it's not an element. Okay? I should have started there when I looked at nickel chloride. I've got more than one element, so it's either a molecular compound or ionic compound. Let's do the same thing here. I've got more than one element, so it's a compound, right? Compound. And I know, I sound patronizing in my voice. Please bear with me. So, are either of these metals? Let's see, nitrogen's right here, so it's a non-metal. Oxygen's right here, so it's a non-metal. So it's covalent compound, it's not ionic. So this is going to be a molecular compound. Okay? And then finally E. All right, so here I've got a metal. Oops, I see more than one element, so it's not going to be, it's going to be a compound, either ionic or molecular. I see a metal here, and I see nonmetals here. Right? Do you see metals and nonmetals? If you do, it is ionic. Okay, and there we go. I hope that's